Hello guys, so today I'll be solving this problem, set intersection size at least 2. So the problem states that we have been given a list of intervals L1, R1, um, L2, R2, okay, like that. We have been given a list of intervals, okay. So what we have to do is we have to build a containing set, okay. Now the containing set definition is whatever intervals that we have here, this set should contain at least two elements from each interval. So yeah, so the containing set definition is this. Now the thing is, it may happen couple of intervals are overlapping. So in that case, some elements will be satisfying uh, like multiple intervals. So with that, we will have dynamic ranges over the length of our containing set. Let's call it S. Okay. So the length of our containing set may vary. So the what is this? Yeah. Yeah. So the question is we have to find the minimum possible size for our containing set. So we have to reduce our containing set size as small as possible. So yeah, that's the question. So in order to solve this problem, we need to know two things. Okay, so first thing is which intervals should we deal first. Should we deal first? Okay, and the second concept here will be for each interval where should we pick elements. Pick elements. Okay, so let's try to answer the first question, which interval should we deal first. Okay, so let's say we have been given an interval uh, 1 3 and 1 and 10. Okay, so between these two, which one should I pick first? Okay, by picking first, like if I want to build my containing set, which one of them should I deal first? Like so from where should I pick element first? Okay, so if I see, so I have 1 3, which is like 1 2 3, then up to we have 10. So I have this and this. Okay, so we can see like 1 and 3 is pretty restrictive. Okay, so there are like lesser number of elements as compared to 1 and 10. Okay, so if I deal 1 and 3 first, okay, then there are chances that whatever elements I pick from 1 and 3, okay, those can be found in 1 and 10 because 1 and 10 is larger than 1 and 3. Okay, so I should pick 1 and 3 first. Okay, then let's take another example. So let's say I have again 1 and 3. Okay, then I have, let's say 2 and 3. Okay, so in this case, which one should I pick first? Okay, so again, so I have 1 2 3. So I have 1 and 3 here. Okay, and I have 1 and 2 here. Oh sorry, 2 and 3 here. Okay, so yeah, here I can see I have 2 and 3. So 2 and 3 has lesser number of elements which are with respect to 1 and 3, right? So if I start solving for 2 and 3 first, then there are chances that those elements will be common to 1 and 3. Okay, so in this case I should solve 2 and 3 first. Okay, so from this we should get an intuition that we should solve those intervals which are smaller in length, right? Or to be more precise, we can say that we can sort our elements in this fashion. Just is this? Yeah. So we should sort our elements with respect to this. So let's consider we have two intervals a and b. Okay. So if a is last or r is equal to b is last, okay, then we should order them with respect to their first element, but we should order them in this manner, in descending manner. Otherwise we should order them with respect to ascending order of their ascending order of r. If we order this like short those interval in this manner, then we will be getting those interval that we should solve first. Okay, so yeah, so first question done. Okay, then what about the second question? For each interval, where should we pick elements? So let's check if I can make another. Does it allow? Okay. So yeah. So to answer this question, okay. So let's see. Um, how can we get overlapping? Okay. So let's say I have an interval L and R. Okay. And after that, let's say I have another interval L dash and R dash. Okay. If I have shortened this in a list of interval in this manner, okay, let's assume this, then if I'm currently in this interval, okay, and I have no idea the next interval whether it will have some overlapping intervals or not, okay, so in this interval, so where should I pick elements? Okay, so there are three regions where I can pick elements. I can pick elements from the starting, I can pick elements from the end, like from the middle, or I can pick elements from the end or the rightmost end. Okay, now let's see what all scenarios overlapping can happen. Okay, so if we sort our interval in this manner, so there are two scenarios of overlapping. So first is I have L and R. Okay, L dash and R dash can be like this. Okay, so this is one case. So in this case, if I pick elements from the first, or I pick elements from the middle, or I pick elements from the end, okay, all will result in common elements with respect to this. Okay, because this interval is overlapping L and R completely. Okay, then the other case of overlapping can happen. I have L and R here. Okay, and I have L dash and R dash something like this. Okay, so if I'm at this interval, okay, so picking elements from the starting will not have any common element with respect to this. Okay, now if I pick elements from the middle, there are chances there might be common elements between this and this. There are chances. Okay, but if I pick elements from the end, so there is a high probability that if I pick elements from the end, then those elements may be uh, fall under this interval. So yeah, so choosing from where we should pick elements, I should always pick elements from the right, because that increases the chance of those elements occurring in my next interval. Okay, provided that my intervals are sorted in this manner. So yeah, this is the greedy analogy behind this question. Okay, so always pick elements from the right end. Okay, and provided that the intervals are sorted in this manner. Okay, cool. Now let's take an example. Okay, maybe I should take another whiteboard. Okay, cool. Now let's take another example. Let's say I have 1 and 4. Is this okay? Then let's say I have 2 and 3. Then I have 2 and 5. Let's say I have 4 and 7. And I have 1 and 3. Okay. So yeah. So first thing first, okay. We should sort the interval in this manner. Okay. So first let's sort them with respect to r. Okay. In ascending order. Ascending order of r. Okay. So I will have 2 and 3. Okay. 1 and 3. Okay. Then I have 1 and 4. Okay. Then I have 2 and 5. And I have 4 and 7. Okay. So with respect to r, I have sorted them in ascending order. Okay. Then I need to sort them in descending order of L. Okay. So 2 and 3 and 1 and 3. Okay. Then with 4 I do not have any ties, so 1 and 4. Then 2 and 5. Then 4 and 7. Cool. So with this I have sorted my elements. Okay. Now let's solve this. So let's write our set here. Okay. So I'm at this interval 2 and 3. Okay. So when I'm at this interval, I do not have any elements in my set. Okay. So I should pick 2 elements from this interval. Okay. So since the length of this interval is 2, so there are only 2 elements. So let's pick the 2 elements. So 2 and 3. Okay. This is done. Okay. Then the next interval I'm getting is 1 and 3. Now if I check for 1 and 3, the last 2 elements that I have picked in my set are already present in this interval, which means I don't need to deal with any elements. Like I don't need to pick any elements in this interval. So this interval is done. Okay. Now let's check this guy 1 and 4. So again, I already have, so the last 2 elements in my set are already present in this interval. Okay, which means I don't need to pick any elements. So this guy is also done. Same thing with 2 and 5. Okay. So I have already gotten 2 elements from this interval. Okay. So this thing is done. Okay. Then the final interval, which is 4 and 7. Now here if I look, so the last 2 elements in my set are 2 and 3. Okay. Why I'm considering the last 2 elements? Because if I start picking up elements in this manner, okay, so the last 2 elements will always be larger ones. Okay. So there is a high chance, so those 2 elements will be present in my intervals. Okay. So that's why I'm picking last 2 elements. But in this case I have 4 and 7. So the last 2 elements are not at all present in this interval, which means I should pick 2 elements from this interval so that my set can satisfy this interval. Okay. So I have 4, 5, 6, 7. Okay. So if I pick 4 and 5, that's also fine. But as per our greedy strategy, okay, yeah, I should always pick elements from the end. Okay, which means I should pick 6 and 7. Now in this question, I do not, like in this example, I do not have any other interval here. Okay, but if we keep picking elements from the end, so whatever next intervals we are getting, okay, so there is a higher chance that those like rightmost elements will be present in the next interval. So yeah, so here the answer will be 4. Okay, cool. I can take one more example here. Okay, so we have 1 3 1 4 2 5 and 3 5. Okay, so 1 3 1 4 2 5 and 3 5. Okay, so same thing, we will sort them in ascending order. So let's call it example A, let's call it example B. With respect to R, so these are already sorted in with respect to R. Okay, then let's sort them with respect to L then. So I do not see, oh yeah, here, so I have 1 and 3. Okay, so this is already sorted with respect to ascending order of R. Okay, now let's sort them with respect to descending order of L. So 1 and 4 and 3 and 5 will come here, and 2 and 5. Cool. Now let's build our set. Okay, initially my set is empty, so I will just pick 2 elements from here. So I will pick the last 2 elements, 2 and 3. Okay, now when I'm picking 2 and 3, so this guy is done. Then I have the next interval 1 and 4. Now in 1 and 4, if I check, so the last 2 elements are already present in this interval. Okay, so I don't need to pick any element from this interval. So this guy is done. Then I have 3 and 5. Now in 3 and 5, what I'm seeing is only one element is common in this interval, which is 3. Okay, so in that case, I need to pick another element from this interval so that my set can satisfy. So I have 3, 4, 5. So this guy is already covered. Okay, so I have two choices. Should I pick 4 or should I pick 5? I should always pick the rightmost element. Okay, as per our greedy analogy. Okay, so I should pick 5 here. Okay, 5. Okay, now my last 2 elements will be 3 and 5. Okay, now yeah, in this interval, if I see 2 and 5, okay, 2 to 5, so if I check my last 2 elements, so those are already present in my this interval, which means I don't need to pick any elements. So yeah, this is my complete set. So if I check, all the intervals are having at least 2 elements in my set. So yeah, 3 is the answer. So if I look, 3 is the answer. So here this guy has picked 2 3 4 just to confuse us, but yeah, we should always pick 2 3 5. Cool. I hope you understand the concept. Let's code it up. Let's start with C++. So first thing, I need to take the length of the intervals. Okay, then I need to short those intervals. So short intervals. Okay, now I'll be using a lambda. So A, auto B. I'll say if there is a tie in the last, with respect tie in R, A of 1 is equal to B of 1, then I will sort them in descending order of their first. Okay, otherwise I will sort them in ascending order of their R. Cool. Now let's create an answer array. Okay, and finally I'll be returning answer.size. So this will be my set. Now let's iterate over all the intervals. Okay, let's capture L and R. Okay, now I'll check if my answer.size is if I haven't picked any element. Okay, which means I need to pick 2 elements from this current interval. Okay, so I'll pick the rightmost elements. So I'll push R minus 1 and I'll push R minus and R. Okay, cool. Now as per the constraint, every interval is of length 2. Okay, and my start I and end I are not overlapping, which means r minus 1, so it will never happen like I'll get an interval whose length is less than 2, or yep. So yeah, I can easily pick r minus 1. Cool. Then I'm done with this. I will say continue. Cool. Now if my ans is not empty, okay, so let's pick the last two elements. So let's say x ans of size minus 2, y ans of size minus 1. Okay, now let's check if these two elements are contained in my current interval. So I'll say bool of contains x equal to x greater than equal to L, and bool of contains y equal to y greater than equal to L. Okay, now if both of them are already present in this interval, yeah, okay, if both of them are present, I don't need to do anything. Okay, I already have, so that means I already have two elements for this interval. Okay, otherwise if only y is there, okay, which means I need to pick one element from this current interval. Okay, so in that case I should always pick the rightmost one, so that we have seen here. Okay, so I should push r here. Okay, now otherwise if there are no, so my last two elements are not at all present in the interval, that means I should pick two elements from this interval. So in that way I should pick r minus 1 and r. R minus 1 and r. Cool. Initial test case passed. Taking time. Cool. We are at the tail. So don't know. I never trust this, but this feels not good. Okay, but if you see here, the time complexity will be so we are doing a sorting here. Okay, so that will be number of intervals log n, log of number of intervals. Okay, and later we are iterating over all the intervals, and not much processing is happening, so we are touching each interval, so that's like number of intervals. Okay, so this is our time complexity here, but the space complexity, if we look, so I have this answer thing, okay, where I'm storing all the elements, but if we check, okay, I'm only interested in the last two elements. Okay, so I don't need a complete data structure or an array to store all the elements. So in this here I have an space complexity of big of n, but I don't need a space. I only need so I don't need an array, I only need the last two elements. So I can do that with some two variables. Okay, so I can say ans is 0, and let's make x and y. Let's pick x equal to -1, y equal to -1. Okay, so if I have this, so I don't need to check whether ans is empty. Okay, simply this will work. So I'll check whether the last two elements are present in my current interval. Yeah, if they are, then I will continue. Otherwise, if one of them is present, okay, then I need to swap. I need to say x will become my y and y will become r. Okay, and if both of them are not at all present in my current interval, which means I need to pick the last two elements. So in that way, x will become r minus 1 and y will become r. Okay. Now I need to increment my answer. Okay. So for the first case, I don't need to include any element to my set. So my set will be of same size. For this case, I need to pick one element, which means my ans will be upgraded by 1. But in this case, in the else case, I need to pick two elements in my set, which means ans will increment by 2. So yeah, finally I will return ans. And yeah, I don't need these declaration. Cool, this works. And yeah, we are still in the end, but right now our space complexity is big O of 1. Okay, but yeah, the time complexity stays the same because we are doing this shorting. Now let's quickly do it for Golang. Okay, so let's capture the length of the intervals. Okay, then we need to short it. So I will use short slice. I will say I need to short intervals. Then I will keep an anonymous function j int, and need to return boolean this. So I'll say if intervals of I of 1 is equal to intervals of I of 1, then I need to sort them in descending order. So intervals of I of 0 should be greater than intervals of j of 0. Yeah, this has to become j. Otherwise, I will sort them in ascending order of right of I of 1, j of 1. Cool. Then the same code that we have written for C++. So ans x, y, I'll say 0, minus 1, minus 1. Okay. Then I need to iterate over all the intervals. And finally, I will return ans. So I'll capture L and R, current intervals L and R. I1. So I'll check whether x and y are contained in this interval. So contains x, that will be x is greater than or equal to L. Okay, and contains y, which means I is greater than or equal to L. Now one thing to observe is that I only need to check this because of the shorting fashion. You may ask a question like, hey, it may happen x and y are less than r, or like more than r. It won't happen because of this shorting. So yeah, cool. And then contains x and contains y. Okay, if both of them are already present in my current interval, so I don't need to do anything. Otherwise, if only y is present, then I need to pick one element from the current interval, which will be r. So in that case, my x and y will take new values. So my x will become y and my y will become r. Okay, and my answer will get increment by 1. Okay, otherwise I need to pick fresh two elements from this interval, which in that case my x and y will become r minus 1 and r. Okay, and my answer will get increment by 2. So yeah, done. Sorry, there are not enough accepted submissions to shoot. Interesting. Cool. But yeah, this is the Golang code. Now let's go for Rust. Okay, so I need to capture the length. So let n equal to intervals len. Okay, then I need to short the intervals. So I'll say intervals short by, I'll use a lambda a comma b, and it takes this, then I will say if a of 1 equal to b of 1, then in that case I will sort them with respect to in descending order of L. So b of 0 compared with a of 0. Okay, otherwise I will return a of 1 should be less than the b of 1. Cool. Then let's create our answer and x and y. So it will be a mutable variable 0, and then similarly for x -1, and let mut of y equal to -1. Then I need to iterate over all the intervals, so 0 to n, and finally I need to return ans. Yeah, now let's capture L and R. So L will be intervals of I of 0, and R equal to intervals of I of 1. Okay, now I simply need to do that if else condition. So yeah, before that I need to check whether x and y are already contained in the interval. So contains x will be x should be less than equal to L. Okay, and contains y will be y should be less than equal to L. Greater than equal to L. So then I will check if both of them are contained in the interval. Then in that case I don't need to do anything, so I'll simply say continue. Okay, otherwise if only y is present, okay, in that case my answer will get increment by 1, and my x will become y, and y will become the rightmost element. Okay, cool. Then if both are not at all present in the current interval, which means I need to pick 2 new elements from the interval, then in that case x will become r minus 1, and y will become r, and my ans will become ans plus equal to 2, so it will get incremented by 2. Cool. And so yeah, this is all the code. I think should work. Let's check. Cannot borrow interval as mutable as it is declared. It is not declared. I don't know what. It is not declared as mutable. Okay. Have changed this to mutable. Okay, let's put a mutable here. Oh, okay, it worked. So submitting. Cool. So it got accepted. So yeah, these two are the concept behind this problem. So we just need to check which interval we should deal first, and when we are picking up elements between intervals, which elements should we pick. So yeah, I hope you guys learned something new, and I was able to explain you the concept behind this problem. So if you find this video helpful, please do like and subscribe. So just stay tuned to watch more videos. Bye bye.